In this video, we're going to talk about how to solve equations for a variable. Sometimes those are called solving a literal equation, and it just means if you have more than one variable, we're trying to isolate one of those variables. So let's look at two together, and then you'll try two on your own. Again, I'm telling you what I want you to solve for on each question. So first, I have negative 2x plus 3y equals 5. We're going to do this just like we did before. We're just going to treat the minus 2x as a constant, so we're just trying to get it away from the variable. So the first thing I'm going to do is add the 2x to each side of the equation. And again, draw your wall if you need to. And the difference here is I'm going to end up with the 3y on the left, but on the right, because 5 and 2x are not like terms, I'm just going to write it as 2x plus 5. Also correct as 5 plus 2x, but just get in the habit of putting the variables before the constants. So now I'm close, but I want to solve for 1y, so I have to divide by 3. So I can divide the whole side by 3 and say that y is equal to 2x plus 5 over 3. Or I could say y is equal to 2/3 x plus 5/3. So it doesn't really matter too much to me which way you do it. Eventually, when we're graphing, you're going to want to write it like this, so it might be a good idea to go ahead and get used to writing it like that. For the second one, we're solving for x. This one I made a little bit harder because, as you can see, I have an x on each side. So just like I did on my last question, I'm going to get the x, all of the x's to one side. So I'm going to choose to subtract cx from each side. Now when I do that, I get ax minus cx, and I still have minus 3. On the right, I have my positive 7. Let's get rid of that 3 because the 3 doesn't have an x, and we want only things with x's on the left. So let's add 3 to each side. That gives me ax minus cx equals 10. And now is where the magic happens because I'm trying to get x by itself. So notice that each of these has an x. So I'm actually going to take an x out of both, kind of like a greatest common factor. Not kind of like it, it is a greatest common factor. And notice if I were to distribute the x, I'd end up back up here again, which is the point. But the purpose of that is that now I can take each side and divide it by a minus c, because what do I have left? I have x on the left side all by itself, and on the right side I have 10 over a minus c, and that is my solution. So here's one for you to try. Go ahead and press pause, then try the question. Press play to check your work. So in this question I'm solving for y, and notice the y is inside parentheses. We've already talked about the fact that we can't really deal with things that are inside parentheses, so we have to get them out. So I'm going to distribute the 5 to get 5x plus 15y equals 7. And I'm trying to get y by itself, so now I'm going to look at the side that has y and get rid of anything that's next to y. So in this case, that would mean subtracting 5x. Again, draw the wall if you need to. 5x from each side gives me 15y on the left. On the right, I have 7 minus 5x. I'm going to write it as negative 5x plus 7. Again, because we have to get used to writing that x value first. Now I'm going to divide by 15. So you can choose to write it either the way I did it before or like this, where I take everything divided by 15. On the left side, that's just y. On the right side, negative 5 over 15 actually reduces to negative 1/3 x, and then plus 7/15. So that is solving for y.